Well, greetings all you YouTubers and YouTubettes. Welcome to the Uncle Doug and Jack channel. And today's prize, which was recently acquired on eBay, believe it or not. My luck's been a little uneven lately with bids and counteroffers on eBay, and it was a real pleasure when the seller of this gem listed it at a reasonable opening price, and I got it. Okay, so without further ado, let's check out exactly what it is I did get. First off, it's a heavy beast, about 21 pounds, for reasons we'll see when I take the cover off. And I was really impressed by this control panel, which appears to be copper. Some of the background paint behind the letters and numbers and all has been lost, and I might be able to rejuvenate that. But all in all, a nice pilot light. It's got a bass, treble, phono, and microphone. So this was probably a PA amp of some sort back in the, let's say, late 40s or maybe very early 50s. Since these two inputs, one with 3 pins and one with 4, are right next to the microphone volume control, I'm assuming these are for microphone input. Probably to make like PA announcements or something like that. This is a problem on old devices like this, because if we're going to use them and repurpose them for guitar use, you're going to have to change these out and put in the standard 1/4 inch input jacks for the guitar, and as we'll see on the back, we're going to have to come up with some sort of output jacks for the speakers. One thing I liked about it was in the ad pictures for the auction, I could tell that it had the original screws in place on the lid, and therefore it probably hadn't been excessively, let's say, screwed up. On the rear, as expected, we have these two outlets, which I'm going to assume are probably for speakers, and then this mysterious one over here for purposes that I don't yet know. Okay, and then of course our trusty fuse and our 3-wire power cord, which was a nice addition. Now let's unscrew the louvered cover and see what lurks beneath it. And what we find underneath is a very pleasant surprise indeed. Let me go to the handheld camera here to take a look at the details of the top structure. Now in the auction ad they removed the cover and showed what was underneath it, so this really isn't that much of a surprise. But you never know until you see it in person. Okay, let's take a look here. There are a couple UTC transformers. I'm going to assume this is an output transformer, and this may be either an interstage phase inverter or a filter choke. We have 4 tubes. Early tubes because of the grid cap on the 6L7s, there's 2 of them. A 6N7, which sometimes is a phase inverter, so this may be the phase inverter and this may not be. And down here a 6SF5. Okay, all lurking down here in preamp territory, I have a feeling. Over here are the metal Abe Lincoln hat style 6L6s, and back here is, surprisingly enough, a 5V4 rectifier, which you know is a high-grade rectifier. This isn't a stinky 5Y3 or a 5U4. This is a dandy rectifier, very similar to the 5Z3. And then here's kind of a mystery tube. Okay, I'm going to pull it out if I can. Ugh. Dang. Okay, it's an amperite relay delay, or delay relay. Okay, I must be dyslexic today. And it's a 6C6OT. Now God only knows what this is for, but it looks like a fairly high current relay of some sort. Maybe when I look underneath you'll be able to figure out what this is for. But I'm not used to having amps other than jukebox amps, which will do have a quick start relay for the output tubes. What this is actually for, I guess we're going to have to see it in action to figure that out. And then finally we have all sorts of capacitors. in these 3 cans. These are really high grade, the Sprague dry electrolytics. This one has 3 10 microfarads at 450 volts, as does this one and this one. Now, it's hard to imagine why you'd need 9 10 microfarad filter caps. I have a feeling that some of these are being used in parallel. That again, we'll have to see when we look underneath. Okay, now before I put that louvered cover back on so we can flip this over, I just wanted to make a comment about buying things like this on eBay. And it is a crapshoot because you really have no idea exactly what you're getting. But when it pays off big, because I'll tell you, for what I paid for this, the whole thing would probably barely pay for this output transformer. So there are some significant deals out there. These tubes have significant value. The power transformer and the other components that are underneath the chassis. Okay, so while not encouraging you to just roll the dice, it is tempting, I gotta tell you, and every once in a while you hit a jackpot like this. Now this was kind of an interesting surprise when I removed the floor pan, which had the little rubber feet and a price tag, it looks like right here. There were some rather crude louvers in it, I guess to encourage circulation. But then when you turn it over, look at this. Designed and constructed by W.E. Grable, 1952. Okay, handwritten on a sheet of thin aluminum, Alcoa aluminum. Now, as we will see when we look inside this thing, it looks anything but hand constructed. Unless W.E. Grable is the darndest fabricator in the world, this thing really does appear to be a factory device. But, in case I'm wrong, if anybody out there has any knowledge about this gentleman, I would love to hear about it. Because take a look at what he built, if he built it. This thing is absolutely incredible. The quality of the wiring and soldering and layout, I've never seen better. Honest to God, this thing is an absolute masterpiece. To cram all of that into this cabinet with a huge ballast resistor and I don't know, a filter choke perhaps over here, really took some ingenuity. Another filter choke over here, God only knows. It's going to take some real exploration to figure out what all these parts are for. As well as, back here, another relay. Okay, so the mysteries just keep growing here around the W.E. Grable amplifier. And something else I find very interesting, which isn't really found in amps nowadays, more in these older ones, is the use of a bus for grounding purposes. Notice this fairly heavy gauge wire that winds its way all the way through the chassis, presenting an excellent ground attachment for any component in proximity to that bus wire. Then the bus wire is securely grounded over here directly to the cabinet. And it's also interesting to see that the bus wire originates at the center tap of the power transformer. You can't talk about a better ground than that. Piece of coat hanger wire connecting right over here to the side of the metal chassis. One part that's fairly easy to interpret, these two wires, which appear to come from the plates of the 6L6s, which pretty well identifies this then as the output transformer. Now over here you'll see we have 0, 8, what looks like 15 and 500. So this will be then the output impedance for the speakers. Those wires will come over here to these weird plug-in connections, these odd sockets, which will probably have to be converted to 1/4-inch jacks to be usable for most remote speakers. And now when I'm viewing from this angle, I'm astounded by the quality of the components. That's a stand core transformer, and over here, it's kind of hard to read, is a Thorderson transformer. So it's obvious whatever the purpose of this originally was, if W.E. Grable built it, he didn't skimp on the price of his parts. Okay, let's make one last drone flight here over this chassis, just to look at the beautiful architecture that W.E. Grable, or someone who knew W.E. Grable, made. You just don't see work like this anymore. Alrighty, now it's time to drag this jewel out into the workshop and start making some tests and corrections and things like that to make it work properly and to work with a guitar and a modern speaker. Two parts that are going to require immediate attention are the microphone and phono volume controls, which are absolutely frozen solid, whereas the tone controls seem to work okay. Now that's got me wondering if the reason all the paint's missing over here is if somebody didn't spray these or try to loosen them up with some sort of solvent that damaged the paint here on the dial. But regardless, I'm going to have to remove these, clean them up, and get them moving properly before we can really continue. Well, it looks like Jack and Ollie are having their morning conversation. Ollie, of course, is here to eat breakfast. Ollie, you hungry? Which is sort of a rhetorical question. What do you think, Jack? Good morning, Ollie. Do you have anything to say to the viewers? No, just where's my breakfast? Oh, there's something. Okay, let's start our repairs of the mighty Grable amp by freeing up these stuck potentiometers. We can see that they are Centralab pots from Milwaukee, Wisconsin. They're very, very high quality. They're very common in older electronic devices, and they're also very easy to take apart and repair, thank heavens. Okay, step one, of course, was unsoldering the 3 leads, unscrewing the outer nut, removing the pot from the chassis. Then we're going to unscrew this inner nut and then pry 2 of these little fingers off of the bow tie flange here, and just one side, pry it off, and then the back will tilt away from the bakelite body. I've removed the outer nut, and then I have used a small screwdriver to pry the rear flange off of the bakelite body. Takes a little bit of strength, but then you can lift it away and it comes apart in 3 pieces, and you're left with that stuck shaft and housing. And the next step will be to release the shaft from the housing and free it up. Now this out here is the contact piece that rubs against the resistance surface inside the bakelite housing. So we want to make sure we don't bend or damage this in any way. But what we're going to do, the way I do it, is I clamp the shaft into my vise, and then I use 2 small screwdrivers to pop this little compression ring here off from the shaft and remove it. Then the shaft is going to push right through the housing and allow us to clean both surfaces and reassemble it. Alright, here I have the shaft of the pot held firmly in the jaws of the vise, and I'm going to use 2 screwdrivers to spread this ring open, sort of like a piston ring. Open it up and then slide it down the shaft and off, so that then the shaft will be able to push back through this house. Okay, as you can see, I have the ring popped out of its groove. I pull it off the end, and now I'm going to probably have to use a pair of pliers on the shaft out here, trying not to damage it too much. But I'm going to try to work this piece with the shaft out of the housing. Okay, I got them apart. It wasn't quite as terrible as some I've seen. I've already cleaned this outer surface of the shaft. You can use fine steel wool to clean and polish it, and then maybe some a roll of fine sandpaper or some abrasives and a Q-tip to clean the inside of the housing. And then ultimately we're going to try to slide them back together so that the shaft moves freely within the housing, like this. Okay, so we have almost no resistance to the rotation. Now to get it back together, we slide the housing back into the bakelite body, put the bow tie in place, and then we're going to run one of the nuts down onto the bow tie to hold it in place for the rest of the festivities. Okay, now that you have your little bow tie held in, you can use your deoxit to spray around here and clean the resistive surface. Don't scrub it or rub it with anything abrasive, but clean that surface so that the pot will be nice and quiet when it operates. Now when we put the shaft and contact piece back in, we're not going to allow the contact piece to enter here where that breach is in the resistive material. We'll bring it over here like about 90 degrees away from it, over here to the side. Okay, the breach is at the top, the contact point is over here on the left. Now look in the lid, be sure that that brown piece of insulating material is in place, and you'll see a kind of a prong sticking up here inside the perimeter of the cap. We want to put that prong on the opposite side of the pot body from the gap that's in the resistance material. The gap is down here. We want to put the prong in up here at the top. Then making sure that the prong in the cap is on the opposite side from the gap in the resistance material, you just put the cap on, push it down, and let it pop back into place. If it's still a little bent out, you can use some pliers or vise to compress these arms together and maybe even push these little pieces here over so that they clamp down on the bow tie. Now the last job is to fit the little piston ring down here onto the shaft. We push it all the way down to the bottom, but it won't be able to seat in that groove unless you will clamp this end of the shaft in your vise, pull back a little bit to expose that groove, and then use your needle nose to tighten the little piston ring down so that it fits snugly in the groove. Now finally, we're going to hook up our digital resistance meter to two of the terminals here on the pot, and then crank it. When you see this is a 500K pot, we're going to crank it down to 0 or thereabouts, and then back up slowly. Digital meters jump around with analog pots, so you got to go slow. But there, we're back up to 500K, and then we can drop down to 0. So it's assembled correctly and it's working. And there you have it. It's all clean, moves smoothly and freely. It's ready to reinstall. And it took longer to explain it than it will do to actually do the job. Okay, so if you ever run across these in any of your old amps that you're trying to work on, don't be afraid to take them apart and clean them up right. Now our phono and microphone pots will be dead quiet and smooth as glass. Okay, I've traced the 0 or common lead from the output transformer and the 8 ohm signal lead over here to these two large 4-pin sockets on the rear of the amp chassis. Now I found that the 0 or common lead connected down here to the bottom right pin of both sockets. They are wired in parallel, and that the 8 ohm signal was sent here to the top left pin of both sockets. Now, the next step would be to pull out these beautifully installed classic old 4-pin speaker sockets and put in 1/4-inch jacks. And I can't do it. I just can't bring myself to butcher this beautifully designed and built amplifier. And out of respect to the individual who constructed this, I'm going to find a way to make this work with a modern guitar and modern speakers, but I'm not going to alter it in any way. And let me show you how I plan on doing it. Step one, I found a 4-pin rectifier tube that I had that was very weak and essentially useless. I broke away the glass globe and all the rest of it, leaving just the base with the 4 pins, 2 large and 2 small, that will fit perfectly into the speaker outlet socket on the rear of the amp chassis. Then I connected a wire to the pin that corresponds to the 0 or common position in the socket, and wired it here to the outer shield or ground on a 1/4-inch jack. I followed that up by connecting a wire between the signal output from the speaker socket to the signal contact on the 1/4-inch jack. Then I cut a piece of brass tubing and silver soldered a body washer onto the end of it with a hole that's about the right size for that speaker jack. This is going to slide all the way down to the bottom so only the prongs are showing. The speaker jack will then protrude here where I can tighten the nut down. Then you can plug in your speaker, plug this into the amp, have a perfect shielded connection without altering the amp in any way. Here's the finished adapter, looking pretty stylish, if I do say so myself. Let's see if it fits. We'll get the 2 large prongs on the bottom. Okay, we'll plug it in here to the rear of the amp. Perfect. Then we'll take our speaker jack, plug it in, and we're ready to go. It looks like an inline fuel filter, except this is a tone filter. Only the good ones get through. Now the microphone input is going to be a little trickier. This is the, well, since the chassis is upside down, this is the bottom microphone input. I think it has 4 pins. And under here is the upper microphone input that has 3 pins. And it's covered with this little metal shield that's been constructed, obviously to cut down on hum and interference. I'm going to remove the shield so we can see what's underneath. Okay, it appears to me that this pin here runs through the resistor and connects to pin 1, 2, 3 of this tube, which I believe is going to be the grid. I'm going to check the tube index and find out for sure. Yes, for the 6 SF5 tube, pin 3 is the grid. Alright, since we know that that's the grid, then my adapter for the input will have to have the signal coming in on this pin, and the shield will have to be connected over here probably to this pin, which is connected to the end of that grounding bus. So now on the outside view we can see I put a little green dot here for the signal input and a little black line here for the shield connection. Now it's time to tear through all of my old vintage electronic plugs and sockets to see if I have one that will fit this. Well, I found one that'll work. It's not a 3-pin plug and it's not polarized, so I have to be careful which way I install it. But as you can see, it fits in there real nice. Now I can wire this to a 1/4-inch jack just like I did the other one and make sure that it has a metal shield on the outside. Well, the mighty Grable amp started right up. I plugged it in, turned it on, and then after a few seconds it quit working. It would just kind of turn itself off. And I've been looking inside here to try to figure out how that might happen, and I have a pretty good idea. There are 2 wires from the 6.3 volt taps of the power transformer that come over here to the base of the relay tube. There are also 2 wires from the 5 volt taps that come to it. Now here's what I think happens. I think it's a thermal relay. 6.3 volts are applied to the relay, which will warm up the tubes. Then once the relay and the tubes have warmed up, the points are closed within the relay that send the 5 volt to the rectifier pins. Now that would be a really valuable addition if the 5 volt contacts could remain closed, but I think what's happening is they stay closed for a little while, and then for some reason they open and stop sending the 5 volts to the rectifier, which shuts down our B+, our high voltage DC, to the circuit. What I'll have to do now is test, or actually watch the relay and see if that's what is happening. If so, I have two options: either bypass the relay or figure out why the relay cannot remain latched. That's liable to be a little challenging. Now, since I'm reluctant to have my 5 and 6.3 volt filament output being sent to a possibly malfunctioning component like that thermal relay tube, I removed all of that kind of unusual white plastic wire that had been added in from the relay over to the power transformer and to the rectifier tube base. The look of it implies to me that it must have been added later on. It's not the same type of wire that was used in the rest of the circuit. Now, however, with no malfunctioning relay in between the 5 volt windings and the rectifier tube, the amp comes on and stays on. Next, I'm going to address the 3-wire power cord, which is okay in itself, but it's got this really clunky, inappropriate plug on the end. So I'm going to replace it with a nice new one. Another issue arose when I was trying to set the bias on the two 6L6 output tubes. The near one here biased out real nice and stable, but the top one would never stabilize the plate current as measured by the voltage drop across this winding of the output transformer. Just would not slow down. It just kept rising infinitely. So immediately it came to mind that one of the coupling capacitors, which are hidden under this platform, was probably to blame. And sure enough, when I removed the upper one, which is on the left, you can see that it was not only leaking DC to the 6L6 grid, it was also leaking out some of its insulating fluid. Okay, so these had to be replaced, and man, I'm telling you, it was a major chore trying to replace them underneath that tower. And there you can see lurking under the platform, right in the middle of the picture, is a giant 0.1 at 600 Mallory, I guess you call it a plum drop capacitor. And of course both of the coupling capacitors were replaced. The other one is down lurking underneath there. And now with those new coupling capacitors, both tubes stabilized and biased at about 12 watts of plate dissipation, which is comfortably under the maximum for these metal-bodied 6L6s, which is around 18 or 19 watts. I want to play it real safe with this and keep it under stressed. Okay, I feel like I'm pretty well finished with this jewel. Let's review what was done. All of the potentiometers were opened, cleaned, and the shafts were freed on these two right here. I replaced the two coupling capacitors for the 6L6s. I raised the input impedance quite a bit. I've got a 1 meg ohm resistor now between the input and the grid of the 6SF5. Anything less than that and the guitar just overpowers the grid. So for sound, that's about the best compromise. I had to replace one electrolytic capacitor, disconnect that slow start relay, and install a new 3-wire power cord. I made a speaker output adapter, and I'm waiting on parts to make the input adapter. Alright, here is the input adapter. I got one of those Reen female 1/4 inch jacks, used a shielded cable over to my little 2-prong plug. Now when I plug this into the amp, I can plug any guitar into the Reen jack and successfully communicate with the mighty Grable amp. So now let's button up the mighty Grable amp and plug in a guitar and see how it sounds. We have the splendid Natco shop speaker connected through the adapter to the speaker output, and at the front the guitar is plugged in to the Reen input. Okay, the pilot light is on, so let's see if we can coax any sound out of this jewel. Well, that's about it for this video on the ancient but venerable Grable hand-built amp. I hope you've enjoyed it. There's still more to be done with this jewel. I've used the upper input, which is probably for the microphone, but have not yet used the lower input, which is for the phono circuit. So that will leave me something to do on another day. Meanwhile, thanks to all the Patreon patrons and PayPal contributors for helping us stay afloat and buying amplifiers like this to be used for video features. If you'd like to join them, please check the video description for links to assist you in doing so. Also, if you'd like to contribute any old tube equipment, working or not, perhaps I could turn it into something that would be video worthy. Now let's return to the car show. I warned you there might be 1 or 2 distractions, but we'll try to stay focused on the cars. Okay, and meanwhile, thanks for watching. Please subscribe if you are so inclined, and by all means stay tuned for future videos. Thanks so much. How's this for a 55 Chevy? Salt flat wheels, which are very expensive. Really nice turquoise color. Looks stock on the outside, but judging from that shifter there on the floor, it isn't. Corvette wheel. Really nice. Speaking of trucks, how about this jewel? Looks like that, what was it, Aztec gold color back from like 1958 or so, 59, which would be pretty close. Look at that interior. Beautiful steering wheel. Man, no corners cut here. If you're going to have a 2-tone seat, I think that one would work. Okay? Just right for hauling compost home for the yard and helping the neighbor move. Oh, look at the bed, Jesus. My kitchen table pales by comparison. Big rear window, gorgeous car, or should I say truck. Now for all you American Graffiti fans, although it's the wrong color and I don't see Suzanne Summers behind the wheel, look at this gem. Somebody must have had a high limit on their credit card. Look at this. Get the Kelsey Hayes wheels, I think. I think that's who made those. I think they made all the original automotive spoked wheels. 4-hole top. Got the old 2-speed automatic. Look at that dash. Wow. Sweet. Oh man. God, is there a square inch of this thing that hasn't been well done? The heater blower has a better paint job than most of my cars. Look at that. Beautiful. I can't help but editorialize just a little bit. And that is, I've always been a Corvette fan. The old, well, any Corvette really, from about 57 to 62 are my favorites. I always thought of these as more like a girl's car, and Corvettes are more like a guy's car. But that's just my sexist prejudice, which I'm sure will earn me some scathing comments. But regardless, I would be glad to be seen riding around in this. Well, all you Smokey and the Bandit fans, and there's got to be some of you who haven't died yet from emphysema, look at this. Get the Screaming Eagle. Nicely done. For cars that are not terribly old, these seem to be real popular and bring a good price. Not from me, but from a whole lot of other people. Pretty slick. This one's a little hard to see because of the shadows, but it's a rather schizophrenic car. I can't decide if it's a 396 or a 350. Odds are it's a 350. And it's really nice. Get the old rally wheels. I like the color, kind of a charcoal gray. Get the tuck and roll seats with rather unusual two-tone choice there. I guess that's so you don't need an interior light. The little bars in your upholstery light up the interior or not. All it needs is a couple Dos Equis there in the console and you'd be ready to go. Pretty slick. Looks like the dogs have all the luck. Look at this thing, Suburban. Doesn't sound like a Suburban, does it? Tasteful upholstery. Horrendous exhaust. A good advertising piece for Midas mufflers. And the always tasteful roadkill sticker. Woo! About to run me over. Thought you'd enjoy the subtle exhaust note with that little chopped coupe. I'm sure the neighbors enjoy it just as much as we do.